Problem 37, a rectangular flume of planed timber with roughness coefficient 0.012 is 1.5 meters wide and carries 1.7 cubic meters per second of water. The bed slope is 0.0006 and at a certain section the depth is 0.9 meter. Find the distance in one reach to the section where the depth is 0.75 meter. So just one reach. So one calculation for this delta x. Is the distance upstream or downstream? So we have to assume that the section where the depth is 0.75 meter is a downstream section. So delta x is specific energy at 1 minus specific energy at 2 over S minus SO. You can simply rederive this if you want, considering depth to 0.75 as the downstream depth, where E1 is velocity head at 1 plus depth 1, E2 velocity head at 2 plus E sub 2. And S is equal to N, mean velocity divided by hydraulic radius mean to the 2/3 quantity square, formula for S. So depth 2 is 0.75. Let's assume that it is in the downstream end. So Q is area to the 5/3 S to the 1/2 over N perimeter to the 2/3. So that we can solve for small q. Capital Q is 1.7 given here. So area is 1.5 meters wide by depth. So let's compute the normal depth. So 1.7 is 1.5 normal depth, which will produce uniform flow. Take note, this is gradually varied because of different depths. Slope is 0.0006, the bed slope, which is also the slope of the energy grade line when the flow is uniform. That's why the depth, will find the normal depth, because these depths here must not cross the normal depth and the critical depth, because these are gradually varied flow. So it will contradict with the principle if it will cross with the normal depth and the critical depth, because the flow is assumed to be gradually varied. So at uniform flow, S of the energy grade line is SO, also the slope of the bed, divided by N. Then perimeter is width plus 2 times normal depth raised to 2/3. So using the calculator, simplify first. 1.7 times 0.012 divided by 1.5 to the 5/3 divided by 0.006 to the 1/2, that's 0.4237. What is left in the right side is normal depth to the 5/3 over quantity 1.5 plus 2 normal depth to the 2/3. Solving for normal depth using your calculator, high-tech, 0.9815 meters, which is greater than 0.9, so it does not affect the depth here. Next, the critical depth. Capital Q is small q is capital Q over width 1.5, so 17 over 15. Then critical depth normal is cube root of 17 over 15 square over 9.81. So the normal critical depth is 0.5078 meters, which is also below 0.75. So in this range, the normal depth and the critical depth do not cross this range of depths. This condition is necessary for us to validate our solution, approximate solution. Or else if it will cross with that, then the solution will be affected, because partially it is uniform. If 0.9, for example, if the normal depth, for example, is 0.88 meters, so it's between 0.75 and 0.9, so it will be affected much. So it should not cross. And 0.5078 is well below 0.75 also. So area 1 is 1.5 times 0.9. Section 1 has depth of 0.9. 1.35. Area 2 is 1.5 times 0.75. 1.12, 125 square meter. So the mean or average area is 1.35 plus 1.125 divided by 2, 1.2375. Hydraulic radius 1 is area over perimeter 1.5 plus 2 times zero point 0.9. The depth is zero point 0.9 at section 1. So 0.4091 meter. Hydraulic radius at section 2 is area 2, 1.125 over quantity 1.5 plus 2 times 0.75. The depth at section 2 is 0.75. So it is 0.375 meters. So the average hydraulic radius is 0.4091 plus 0.375 divided by 2. So it is shown here, except the average area because you just get the average, 0.39205 meters. From here, we can solve the velocity 1, which is Q over area 1. So 1.7 over area 1, 1.259 meters per second. V sub 2 is 1.7 Q over area 2, 1.125, 1.511 meters per second. So the average velocity is 1.259 plus 1.511 divided by 2, again not shown here, 1.285 meters per second. So from there, we can now compute the slope of the average slope of the energy grade line, which is quantity n Vm over hydraulic radius mean to the 2/3 quantity square. So 0.012 mean velocity 1.85 over mean hydraulic radius to the 2/3 quantity square. That's just formula for slope. So slope is 0.0009627. So finally, we substitute it here. Delta x is equal to velocity head at 1.259 square over 19.62, v1 square over 19.62 plus depth 1.9 minus v2 square over 2g, 1.511 square over 19.62 plus depth 2.75 divided by s minus so. So if the result is positive, our assumption that section 2, where the depth is 0.75 is downstream, is correct. But if the result is negative, it is the other way. So the downstream section is the one with depth 0.9 and the upstream section is the one with depth 0.75. So because the result is positive, then 15.5 meters, so the assumption that the depth of 0.75 meter is in the downstream end. So that's it.